Good day, learners! I am Miss Tin, your Guru Kamigo. Welcome to another fun and exciting learning with me. Today, you will learn about measuring motion in terms of distance and time. At the end of this video lesson, Grade 5 learners are expected to describe the motion of an object by tracing and measuring its change in position over a period of time. It's now our third grading period, and I want to know if you can still recall some of the lessons we had. Now let us try to do simple activity to help you freshen up and recall our past lesson. Ready? Get your notebook or your paper and pen. Then, be ready to record or write your answer. Can you give some of the things you should do as grade 5 learners to contribute in protecting and conserving water resources and other living organisms in the intertidal zones and estuaries? Here are the things you can do at home and in the beach. As much as possible, avoid using synthetic fertilizers. Plants do not absorb them completely, and it can wash off into our streams and waterways. Use natural fertilizers instead. Trim grass clippings from your lawn can be used as a natural fertilizer. Cut grass moderately. A little height can make the roots move deeper and may lessen erosion. Grow plants in your garden. Choose plants that are native to your area so that it would need less water and fertilizer. Dispose toxic products properly. Improper disposal may pollute coastal rivers and estuaries. Remind your parents to pump your septic tanks at least every 3 years. Use non-toxic pesticides, examples of which is a mixture of soap water and chili pepper. Excessive use of toxic pesticides can pollute nearby waterways. Look for natural alternatives to chemical-based household products, examples of which are table salt and baking soda. Leave our beaches clean. Always pick up your trash and dispose it properly. Do not disturb or keep animals that you found along the shoreline. Avoid using motorized boats in sensitive habitats. Use canoe or kayak if you want to snorkel near the coral reefs. When on a boat, avoid throwing your trash out to the sea. It is good to know that you really learned a lot from our past lesson. Now, you are more than ready for our next topic. Look at this picture. What does the children do in the picture? Yes, they are playing. Do you know what you call to that traditional Filipino game? Yes, it's tumbang preso. Do you experience to play tumbang preso with your friends? Okay, that's nice. What are you going to do in order to win the game? Okay, so you should run fast, use the right flip-flops, not too light, not too heavy, and of course, practice your aim and react fast. Do players need to move while playing the tumbang preso? Yes, of course. Why is it important to move around and let the tin be fell on the ground after it was hit by the opponent player? Okay, very good, to avoid from being tagged. Body movements in any games are necessary to play the game properly and of course to win. Motion and energy are relatively important in our daily life. Motion and energy work together to make things easier for us. Through the help of force, motion can be achieved. Without motion, we cannot do work and enjoy life. Life is so boring without any movement or any motion in it. What is motion? It seems that everything is moving. By definition, motion is a change in a position with respect to its reference point. From the time you wake up until you go to sleep, all our activities involve movement. We have to move in order to complete our tasks. Motion will always be a part of our daily life. The first picture is a moving train on its track, which is an example of rectilinear motion. The next picture shows the Earth revolving around the Sun, which is an example of periodic motion, because the motion of an object repeats itself after a certain period of time. The last picture is a Ferris wheel, wherein the motion of an object is in a circular path called circular motion. Observe Figure 1 and Figure 2. Infer in which figure the car has moved. Is there a change in the position of the car in Figure 2? Yes, there is a change in the position of the car in Figure 2. What does the change in position of the car in Figure 2 mean? The change in position of the car in Figure 2 means that the car has moved. There is motion. How do we know the car has moved? We know the car has moved because it changes position. What is your basis in describing the car's motion? The basis in describing the car's position is the reference point or frame of reference. You know that something has moved because you can see that it has changed position. Position is the location of an object. It is an object's distance in direction from a reference point. A reference point, also called frame of reference, is a fixed place or an object used to determine the position of the object. The car in the first activity has changed position when it was a meter away from the trees. This process of changing an object's position is called motion. The activities that you are going to perform will clearly describe what causes the object to move. Also, you will measure the distance covered by a moving object, which is affected by the speed or the measure of how fast it moves. Here is your first activity. Remember this, grade 5 learners. Pull or push as part of exerting force may also relative on the distance on the object when it is moved from one point to another. However, distance is the measure of how far or near 2 points are from one another. It can be measured using different ways, such as time, landmark, or body parts. For example, when you are going to school, the distance of the school from your house is 2 kilometers away and you spend 1 hour of walking just to get there in your school. This may not validate that you spent less time going to school than going to church, which is far apart from the school. There are factors to be considered like traffic or winding road that can be affected your travel time. Therefore, there are appropriate tools and ways to measure distance so that you can tell whether the object is near or far. Distance is measured by using tools such as meter stick, tape measure, measuring wheel, and ultrasonic distance measurer. On the other hand, distance covered by a moving object is affected by speed, or the measure of how fast it moves. Speed of an object can be calculated by dividing the distance covered by an object in motion by the time spent to cover the distance. Here is the formula. Speed equals distance covered divided by time, or S equals D divided by T. For example, Tess traveled 5 meters away with her bike from her house going to plaza in 120 seconds. In getting the speed of Tess' bike, following the formula stated above, speed equals 5 meter divided by 120 seconds. The speed of Tess' bike is 0.42 meter per second from her house to the plaza. At this moment, you are going to name at least 5 of your daily activities and describe how motion takes place. For example, walking. So when we walk, we change our original position to the place where we are going. For the next activity, analyze and solve the problems. Then, fill in the table with the needed information. Problem number 1. A cyclist travels 200 kilometers in 8 hours. What is the speed of the cyclist? The distance is 200 kilometers, time 8 hours, and the speed is 25 kilometers per hour or 6.94 meters per second. Number 2. A mouse runs a distance of 2 meters in 15 seconds. What is its speed? The distance is 2 meters, the time is 15 seconds, and the speed is 0.13 meters per second. A car travels 300 kilometers in 5 hours. What is its speed? Distance is 300 kilometers, time 5 hours, and the speed is 60 kilometers per hour or 16.67 meters per second. Number 4. A man runs 108 kilometers in 3 hours. What is his speed? Distance is 108 kilometers, the time is 3 hours, and the speed is 36 kilometers per hour or 10 meters per second. Number 5. A tricycle drove to a passenger's house that is 20 meters away from the station in 10 minutes. What is the speed of the tricycle? The distance is 20 meters and the time is 10 minutes. The speed is 0.033 meter per second. Grade 5 learners, remember that in describing the motion of an object by tracing and measuring its change in position over a period of time, you need to take value on the importance of having a standard unit of measurement in determining the distance between 2 points. Knowledge and conversion is also necessary to get the speed of a moving object. Now let us try to solve this word problem. My Santos family always get together during weekend. They plan to go to Tagaytay with their new Toyota Rush. Tagaytay is 70 meters away from their home and they tend to get there in just 35 minutes. What will be the speed of the car needed to land in Tagaytay? What are given in the word problem? We have distance, which is 70 meters, time 35 minutes, and the formula in finding the speed is distance divided by time. So, 70 meters divided by 35 minutes, but first you are going to convert 35 minutes into seconds. So, it would be 35 times 60. The result is 2,100 seconds. Now, 70 meters divided by 2,100 seconds would be 0.33 meters per second. Grade 5 learners, to check your understanding about the lesson, you are going to read the question and choose the letter of the best answer. Number 1. A change in an object's position is called blank. A. Force, B. Motion, C. Pulling, D. Pushing. Very good. The answer is letter B. Number 2. How do you know if an object has changed position? A. It is not visible anymore. B. It looks bigger. C. It is farther or closer from a reference point. D. It is on top of a reference point. Very good. The answer is letter C. Forces have both blank. A. Magnitude and speed. B. Direction and speed. C. Magnitude and direction. Good job. The answer is letter C. The distance traveled by an object per unit time is called blank. A. Velocity, B. Speed, C. Momentum, D. Acceleration. Very good. The answer is letter B. The property of an object that resists change in its motion is blank. A. Mass, B. Inertia, C. Velocity, D. Momentum. Very good. The answer is letter B. A force that resists motion created by objects rubbing together is blank. A. Gravity, B. Friction, C. Speed, D. Force. Good job. The answer is letter B. A force that pulls objects toward each other is blank. A. Force, B. Frame of reference, C. Gravity, D. Kinetic energy. Nice! The answer is letter C. An example of balanced forces is A. A person skating back and forth on an ice rink. B. Tire with treads gaining speed on an icy road. C. Two soccer players running in opposite directions. D. A book resting on a desk. Nice! The answer is letter D. A force that sets an object into motion is blank. A. Balanced, B. Friction, C. Unbalanced, D. Inertia. Good job! The answer is letter C. Velocity is a measure of speed that takes into account the blank. A. Weight of an object, B. Direction of movement. C. Force of the movement. D. Acceleration of an object. Very good. The answer is letter A. For the final part of this video lesson, you are going to reflect on what you learned about measuring motion in terms of distance and time. Complete the following statement. The part of the lesson I believe I learned most about is blank. The task which I found most challenging blank because blank. I realized that I can use what I have learned from this lesson when blank. That ends our lesson for today. I hope you had a great time learning with me. Thank you for watching. See you next time.